So many pieces all back together now. What's your vision?
Assalamualaikum and a very good morning. Today I'm going to explain about half-wave rectifier. Before I start explain half-wave rectifier, I want to talk about rectifier. A rectifier is an electrical device that convert AC, which periodically reverse direction, to DC, which flows in only one direction. This process is known as rectification. Rectifiers take a number of forms, including vacuum tube diodes, mercury arc valve, stacks of copper, and selenium oxide plates, semiconductor diodes, silicon control rectifiers, and other silicon-based semiconductor switches. Rectifiers have many uses, but are often found serving as component of DC power supplies and high voltage direct current power transmission system. Depending on the type of AC supply and the arrangement of the rectifier circuit, the output voltage may require additional smoothing to reproduce a uniform steady voltage. Now we talk about the half-wave rectifier. In half-wave rectifier of single-phase supplies, either the positive or negative half of the AC wave is passed, while the other half is blocked. Half-wave rectification requires a single diode in a single-phase supply, or 3 in a 3-phase supply.
As you can see over here, the input signal is applied to load through this diode. So whenever the sign is applied as an input, then the output you will get this kind of waveform. So here this current only passed the positive half cycle sine wave and completely rejected the negative half cycle. So now how the circuit works, and for the analysis purpose for the moment, let I zoom that. This diode is an idle diode, so during the positive half cycle the voltage will be positive. In simply, we can replace the diode become closed switch. So this enter voltage will appear across the load. So during the positive half cycle from 0 to T/2, the complete input will appear across the load. Now during the negative half cycle, the voltage which appear will be negative. So this diode will get reversed. So simply it will be open switch. So current flow to the circuit and the output we will get 0 voltage. During the negative half cycle, we will get 0 voltage. And this way, whenever the continuous sine wave is applied as an input, and the output we will get either positive or negative. Now, so far in our analysis, we are assuming that the diode which is connected in the rectifier is an idle diode. But now, we can consider that voltage drop across the diode. Here, we are assuming that the connected diode is silicon diode. It means that it has voltage 0.7. The input voltage more than 0.7. So now the circuit will start conducting only during this period. So during the positive half cycle, if you see the output value, it will look like this. And if you see the big voltage at the output, it will slightly less than Vm, because now we also considering the voltage across the diode, it will be equal to Vm 0.7. Now, during the half cycle, the voltage will appear across the diode will be negative, and simply it will be open circuit. And output voltage across the load will be 0. So during the negative half cycle, we will get 0 voltage, and most of the cases during the rectifier process, Vm used to be a much larger than Vd. So the output wave of the rectifier will be much closer to the ideal waveform, and in that case, we can simply the voltage drop across the diode.
The primary application of rectifiers is to derive DC power from an AC supply, AC to DC converter. Rectifiers are used inside the power supplies of virtually all electronic equipment. AC-DC power supply may be broadly divided into linear power supplies and switch-mode power supplies. In such power supplies, the rectifier will be in series following the transformer and be followed by a smoothing filter and possibly a voltage regulator. In half-wave rectification of a single-phase supply, either the positive or negative half of the AC wave is passed while the other half is blocked. Mathematically, it is a step function for positive pass, negative block. Passing positive corresponds to the ramp function being the identity on positive input. Blocking in negative corresponds to being zero on negative input. Because only one half of the input waveform reaches the output, mean voltage is lower. Half-wave rectification requires a single diode in a single-phase supply.